Alright guys, so we're going to go ahead and look at the Polynomial Test 1 review. There are too many problems for me to go over, but I will go over the ones I've gone in beforehand. I've circled the ones that I want to work. Obviously you, for a little bit of practice, would want to maybe look at the others that I haven't circled. And I'll work through these pretty fast. And I have my extra sheet of paper for my scratch work. I'll try to work through these pretty fast, and as I work through them, I'll explain them as I go. Okay, so number 1 says simplify. You'll see this word over and over again on your test. Simplify just means cancel out whatever you can, combine whatever like terms you can. So for the first one, they say write the expression presented by the tiles. Remember that whenever they're shaded in, they're negative. Whenever they're not shaded in, they're positive. Alright, the big ones are obviously x squared, so my expression is negative x squared plus x squared minus x plus x plus x squared plus x plus 1 minus 1. We go through and we want to simplify our expression, so I'm going to go ahead and cross these out. Anytime that you have a positive term and a negative term, they cancel each other out. That creates 0 pair, so 0 pair there, 0 pair there, 0 pair there. I'm left with this right here. So I'm left with x squared plus x plus 1. Alright, again, questions through 2 through 10, again, say simplify the problem below. So we're pretty much doing the same thing, obviously this time without the tiles. So simplifying my problems below, we have 3x squared. Let me see if I can zoom in. We have 3x squared minus 4x plus 7 minus 7x squared plus 6x minus 2. So with my students, I always tell them to make themselves a table. It really helps you stay organized. Your table is x squared, x's, and numbers. All you want to do is just simply put these terms into the table where they go, and then add them together right down the row. So starting with 3x squared, that's going to go in here, minus 4x goes in here, plus 7 goes in there. Alright, so I've done these 3. Now I go into these. Always make sure that you put them in with their signs. And then from here we just add them together. You can do this in your calculator or in your head. For example, like the first one you might want to do in your calculator. Obviously we can't type in x squared, but we can do 3 plus negative 7, which gives me negative 4. My column is x squared, so that's going to be negative 4 x squared. On this one, negative 4 plus 6 is going to give me 2 x, again because that's on the column. And then this 7 minus 2 is going to give me 5. So my expression here is going to be negative 4x squared plus 2x plus 5. Make sure that the negative is visible. And we can really do the same for all of these. Number 3, same thing. I want to make myself a table. Again, put my terms where they go. 2x squared minus 4x plus 1 minus 5x squared plus 3x minus 9. And again, we add them down your column, the category stays the same. So this one is 2 minus 5, or in other words, 2 plus negative 5, which is negative 3, x squared, negative 4 plus 3, negative 1, and then 1 plus negative 9. So this time my expression is negative 3x squared minus 1x minus 8. Right, so it's pretty straightforward on how we solve these. The next set of problems that I wanted to go over are 4 and 5. The reason I wanted to go over these is because these have parentheses. Now whenever something has parentheses, that means that I cannot immediately just take them and put them in my categories just like I did earlier. The very first thing I have to do then is I have to take them out of the parentheses. You do that by multiplying by the number in front of the parentheses. Now, I always go through with my pen or pencil, and I always circle what's in front. So in front of this set of parentheses here, we have this, which doesn't look like there's anything there. Remember that in algebra they won't show it to you, but there is actually an understood 1 there. And really that's what I'm distributing, is that understood 1. So I'm doing 1 times negative 3x, 1 times negative 4x, and then 1 times 5. Well, anytime that you multiply anything by 1, the value itself does not change. So 1 times negative 3x is actually negative 3x squared. 1 times negative 4 is actually negative 4x. 1 times 5 is actually 5. Right, so my values don't change. In fact, all they really do is just drop down. When I'm trying to get rid of the second set of parentheses, I actually do the same thing. I multiply by the thing right in front of it, which right now is a plus. And again, just like the previous one, in Algebra 1 they won't show it to you, but there's actually an understood 1 there. So this time it's the same as last time, it's a positive 1. So I'm distributing positive 1 into all of these. Remember, when we do distribution, we're multiplying. So this is 1 times 8x. So we take all three of our terms. We can then put them into our table. And then we can combine all our like terms. So we have negative 3 plus 8, which is going to give me 5x squared. Negative 4 plus negative 5 is going to give me negative 9. And then 5 minus 2 is going to leave me with 3. So my simplified expression is 5x squared minus 9x plus 3. We'll do number 5. Just like number 4, number 5, the understood number in front of the parentheses here is 1. When we distribute everything, when we distribute 1 to everything, the value does not change. So my first set of parentheses, all they really do is drop. My second set of parentheses, however, we have a negative there, and I can put a 1 once again in there. This time I'm distributing a negative 1. Negative 1, just like the 1, doesn't really do much. But this time, since it's negative, what's going to happen is that all of your positive terms are going to go into and become negative terms. All of your negative terms are going to switch and become positive terms. So all you do is just go through and switch the signs when you're distributing by a negative 1. So the positive 4x is going to become negative 4x squared. Sorry, positive 4x squared becomes negative 4x squared. The negative 2x becomes positive 2x. And the negative 6 becomes positive 6. That's what happens when we distribute by negative 1. Alright, just like the previous one, we're going to go ahead and draw this onto our table. Negative 3x squared minus 2x plus 1. Negative 4x squared plus 2x plus 6. Again, the double negatives always throw students off, or that's where the mistake will usually happen. Make sure that you're just typing these into your calculator. Negative 3 plus negative 4 gives me negative 7 x squared. Negative 2 plus 2 gives me 0. Since it gives me 0, I'm not even going to go in and write 0x. Really what that means is that these two things cancel each other out. And then I have 1 plus 6, which leaves me with 7, positive 7. Since my middle term canceled out, I'm going to squish these back together. And so my final answer is negative 7x squared plus 7. And that is my solution to that one. There is no middle term. There is no x. Alright, I'll skip the rest of these just so that you guys, if you want to have some sort of practice, you can. I'm going to jump down to number 10. I like number 10 because it's a little bit different from our traditional, the ones that we've seen. They've all kind of been in order. So working number 10 it kind of is a little bit different. All right, so with number 10, again, we want to get rid of the parentheses first before we get them into our categories. So very first thing I do is distribute by 2. So I'm going to do 2 times x squared, which is going to give me 2x squared. 2 times negative 3x, which is going to give me negative 6x. For the second distribution, once again I'm distributing this time the negative 1, which we talked about earlier. All that does is just change your signs. So the positive x becomes negative x, and the negative 7 becomes positive 7. Then this 5x squared, since it's not in parentheses, just comes down. Plus 5x squared. Once again, we go into our table. So I have 2x squared minus 6x. Then the minus x actually goes in here. Then we have plus 7. And then we have plus 5x squared. Okay, so this time our numbers or our categories were a little bit jumbled up, so you had to make sure that you got them into the right spot. We add down the row, so 2 plus 5 is going to give me 7x squared. Negative 6 minus x, it really helps if you put a 1 here, just for yourself. That way you understand that it's negative 6 plus negative 1. Which again I can show on my calculator. Which gives me negative 7. And again, you see how my categories never change, they stay the same. And then the plus 7, since it has nothing, just comes straight down. So this is going to be 7x squared minus 7x plus 7. Again, I remind you that our directions were to simplify, and that is what simplify means. Simplify just means, can you combine all of your like terms? Can you get rid of parentheses? Can you put them into categories like this and add them together? All right, so we'll go to the next page. Now we go into a bit of multiplication. Again, I went in ahead of time and said, okay, which problems do I want to work? So I've gone in and circled the ones that I want to show you guys. Your directions are find the product of each of the following, show all work on a separate sheet of paper. So again, here's my separate sheet of paper. All right, so number 11. We have 2x, 3x plus 4. I'll show you guys both ways that you can really solve this with the box method and with double distribution. I'll go to start with the box method. So the box method, we're multiplying one term times two terms. In other words, a monomial times a binomial. So we need two boxes, or in other words, a 1 by 2 grid, which is going to look like this. If you're not 100% sure, you can always do a 2 by 2 and then just kind of fill it in as you go. My one term, my monomial, is going to go out here. My binomial gets broken up into its two parts, 3x plus 4. When we multiply, I always say we do number with number, letter with letter. So we do 2 times 3, which is 6. And then x times x, the letter with the letter. X times x gives me x squared. Or in other words, you can count how many x's go in. That x and that x, they both go in, so together they give you x squared. For the second box, we do same thing, number with number, 2 times 4. Don't get thrown off by the plus. 2 times 4 is 8. We always multiply our way in. And then how many x's track their way in here? So we have 1x coming from there, nothing coming from there. So we have 1x coming in, so I have 8x. I take my terms out of the box, combine whatever I can. Since x squared and x's don't combine, that is going to be my final answer. Number 12. This time it's x times x minus 5. Once again, I'll show this with the box method. Once again, we have two boxes. Alright, so once again I multiply in, this time number with number, my numbers aren't there, so I don't worry about them. X times x gives me x squared, and then x times a number. Anytime that you have a letter times a number, you just stick them together. So negative 5 times x gives me negative 5x. Once again, we bring them out of the box. And there's nothing to combine, so I just leave it as x squared minus 5x. 13. I'll show 13 with distribution. For those of you guys that want to see distribution, Distribution is basically the box method, just without the, going out and drawing the boxes. So we go through and we distribute. So we do 3 times 4, which is 12, and then x times x, which is x squared. Then I distribute again, 3x times this time. Remember that the sign sticks to this one, so it's a negative 5. So 3x times negative 5, which is going to give me negative 15. And then there's 1x that goes in, so negative 15x. Okay, and that's double distribution. Again, if this was the box method, those two would be in the boxes like these two were. Okay, so then my answer here is 12x squared minus 15x. Now with the distribution, double distribution, I would encourage, if you're good at distribution, for you guys to do this one. Unless, of course, you like the box method. But if you're struggling with multiplying your polynomials, then I would say the box method is the better choice for you. But again, it's all pretty much just preference, whatever you like. All right, number 16. 16 is x minus 2 and x plus 2. Okay, so again, if I do my box, again, I'll show this one with the box. This time it's a binomial times a binomial, 2 terms times 2 terms, so we need 4 boxes. It really doesn't matter where you put the x minus 2 and the x plus 2, you end up getting the same thing. Alright, so I have x minus 2 and x plus 2. We multiply our way in, so we have x times x gives me x squared, x times negative 2 gives me negative 2x, x times positive 2 gives me positive 2x, and then 2 times negative 2 gives me negative 4. And always make sure that you're multiplying your way in. Alright, from here we transfer our answers, or actually let me get all my terms out of the box. Now with this, I tell my students there's 2 ways for you guys to do these. You could go back into your table just like we did earlier. So you could do this. And some of my students really like doing that, because then all I really do is just take each of these terms and put them in one of the categories. It would look like this. Anything that's by itself is just coming straight down. These two I would combine, which again, if we combine those in our calculator, again, you never put in the letters, so it's negative 2 plus 2 gives me 0. Again, since I have 0 as my term here, I'm not going to write 0x. I'm also not going to write x. If you get 0, that means that these two things have canceled each other out. That creates a 0 pair, so that whole thing is gone. Since that whole thing is gone, we take our terms and we squish them back together, and that's going to be our solution. Okay, so sometimes the middle terms will cancel. Whenever the middle terms cancel out, take them out completely and just leave the first term and the last term. Alright, we'll do 17. With 17, I'll show you guys the other shortcut. Alright, so once again I can do the box method. So x times 3, it all depends on how you want to do it. You can put a 1 there. And so now you have 1 times 3, which is 3, x times x, which is x squared, 3 times 4, which is 12, and then 1x went in. 1 times negative 5, which is negative 5, and then 1x comes in from the top, and then 4 times negative 5, which is negative 20. Alright, here's your shortcut in the box method. From our chart from the previous one, we realized that, hey, the only thing that we ever really combine are the x's, are the middle terms. So whenever I'm doing my box method this way, I can actually say, hey, these are the ones that combine. So I could actually just go through, circle those like that so that I remember to combine them, and then everything else just stays in a row. So this 3x squared is not going to combine with anything. In my head or in my calculator, I would add these two together, 12 plus negative 5, or in other words, 12 minus 5, which is going to leave me with 7, and then the negative 20 comes down. So this, if you do it this way, then you go around having to draw your table. If you just go in and say, hey, those are the two that I'm going to combine every time. You combine them, and then that is your final answer. Alright, last one is 18. 18 does look a little funky. It has 4x minus 7 squared. So we'll talk about how to write it out first. Alright, so from when you guys were doing division, you learned that anytime that there's a squared there, it just means that we are doing this twice, right? Just like when we were expanding our terms out, if we had, for example, w to the 4th power, the 4 would tell you how many times to write the w, so you would say w times w times w times w. Alright, so it's actually the same thing here. That 2 tells you to write this thing twice, so this is actually 4x minus 7 times 4x minus 7. I can show this last one with double distribution. Again, with double distribution, you're going to take your first term. You're going to distribute it to the second set of parentheses, which is over here. And we're going to distribute it to both terms. So we're going to do 4x times 4x. 4 times 4 is 16. X times x is x squared. Then I'm going to do 4x times negative 7. Remember that the sign sticks to it. It's going to give me negative 28x. Okay, once I'm done with that one, then I'm going to take my bottom term, multiply that one out. So now negative 7 times 4 gives me negative 28x, and then negative 7 times negative 7 gives me positive 49. I take my two middle terms, I add them together, so now my final answer is 16x squared minus negative 56 x, and then plus 49. Okay, so my final answer on this one is going to be 16x squared minus 56x plus 49. Alright, we'll shift gears. We'll jump to 22 is very similar. You know, you have the bedroom, that's the length, that's the width. To find the area, you just do length times width. So really it's like just one of these problems. Alright, 23. 23 says Taylor has a square area rug in his living room that is 2x feet long on each side. The room is 2 feet wider and 6 feet longer than the rug. Find the perimeter and area of the living room. So we're going to go ahead and draw his living room first. So he has a rug, a square rug, that's 2x by 2x. His room is 2 feet wider, so his room goes 2 more feet. And it's also 6 feet longer, so it also goes not just to there, but past it, goes 6 more. Six more feet. We want to find the perimeter, and we want to find the area of his living room, not the rug, of the living room, so the whole thing. So basically we can take these two, simplify them into 2x plus 2. We can take those two, simplify them into 2x plus 6. Right, that's what happens when you add so many feet to each side. All you're doing is just adding it to what the dimensions already were. So for perimeter, if this is 2x plus 2, then this is also 2x plus 2. If this is 2x plus 6, this is also 2x plus 6. So to find my perimeter, I'm going to add up all four sides. So again, this helps if we draw our table. We have 2x plus 2's. We have 2 of them. And then we have 2x plus 6. In this instance here, I don't have any x squared, so I don't worry about that. We do 2 plus 2 plus 2 plus 2, which gives me 8. And then there's x's, so I put x. Then I do 2 plus 2, which is 4, 4 plus 6, which is 10, 10 plus 6, which is 16. So my perimeter ends up being 8x plus 16. For area, we're going to multiply. I can do double distribution again since I only technically did it once. Double distribution for this, we're going to do, again, length times width. So I'm going to let that be my length. Let this one be my width. So that's length, that's width. Length times width. So we're going to do 2x plus 2 times 2x plus 6. And we multiply those out. Again, if we're doing distribution, we take our first term, we're going to multiply it times these two. So we're going to do 2x times 2x, so 2 times 2 is 4. X times x is x squared. Then we do 2 times 6, which is 12. And then x. Alright, so 2x times 6 is 12x. Next I take my plus 2, my positive 2, and I'm going to distribute that. So positive 2 times 2 is going to give me 4x. And then positive 2 times 6 is going to give me 12. I combine my two middle terms. So we have 4x squared. 12x plus 4x gives me a total of 16x. And then the 12 comes down. So my area is 4x squared plus 16 plus 12. Next, 24 says find the area of the shaded region below. So for 24, we have to find the area of the shaded region, so just this part in here. We don't want any of the non-shaded region. You guys should, in math class, have done this problem probably 2 or 3 times by now. But I'll go ahead and break it down. We're basically going to do area of the big one. That's going to be our first step, is finding the area of the big. Second step is going to be finding the area of the small. And then step 3 is going to be to go in and subtract the small one from the big one. That's step 3. Okay, the reason that we subtract is because if we find the whole area of the big, we're actually finding this whole thing, and we don't need the whole thing. So when we go in and we find the area of the whole thing, then we have to go in and find the area of the little one. Once we find the area of the little one, we can take that away from it, and then so that leaves us with the remaining area that we want. Alright, so we have to go in and we have to multiply. So area of the big, I'm going to do big length times big width, which is 5x times 6x. Well, this is, if I do distribution, is only going to be 1. So 5 times 6 is 30. And then x times x is x squared. So area of the big rectangle is 30x squared. Great. Now I do area of the small, which is 2x times 3x minus 2. And I'm going to distribute once again just because of my lack of space for doing the box. So I'm going to do 2 times 3, which is 6, and then x times x, which is x squared. Then I'm going to do 2x times negative 2. So 2 times negative 2 is negative 4, and then there's an x. Okay, so that's my area of my small. So I've done both. I've done area of big, area of small. Now I have to figure out what happens when I subtract one from the other. So I'm going to do area of the big minus the area of the small. Now here's the thing. I always tell my students, make sure that you put them in parentheses so that you don't make any mistakes. So we're going to put that in parentheses, we're going to put this in parentheses, and we're going to subtract the big one from the small one, or the small one from the big one. I put them in parentheses so that I can technically take them out and I can simplify it a little bit easier. So what that means is I'm going to go ahead and take the first term out of the parentheses, so I'm going to multiply by whatever's in front. In front of it is an understood 1. Right, so when I multiply this by 1, the value doesn't change, it stays 30x squared. That's not what I really do it for. I do it really to get the second term into the simplified term. This is going to be a negative 1. If I distribute negative 1, then again what that does is it just goes in and changes all the signs. So 6x squared now becomes negative 6x squared. And then negative 4x squared, that becomes positive 4x. Or sorry, positive 4x. Negative 4x becomes positive 4x. Now that I've gotten them out of their parentheses, now we just go in, draw our table, and then combine like terms, and we're done. Alright, so 30x squared is my first term, that's going to go in here. 6x squared, negative 6x squared is going to go in here. 4x goes in here. And that's it. In this case, I don't have any numbers, so I don't have to worry about that. Really, the only thing I have to combine are these two. So 30 minus 6 is going to leave me with 24. And again, the category is x squared. And then 4 comes down. So my area of the shaded region is going to be 24x squared plus 4x. Alright, shifting gears, going to the next page. Let me grab another sheet. Alright, so 25. 25 is a cone. It says Anthony needs to find the lateral surface area of the cone shown below. He uses the formula S equals pi RL, where R is 2x, L is 4x plus 4. Which of the following expressions represents the surface area of the cone? So what you're supposed to do is you're supposed to go and simplify this for him. Now one thing that they do is they have pi, right? But in their answer choices, they never actually go in and distribute the pi or do anything else with the pi. So we actually don't have to do anything with pi. All we have to do is go in and simplify this part. So we are going to go ahead and multiply 2x times 4x plus 4. I'll go back to doing the box. Again, I want to try to keep it almost half and half. So 2x is my monomial. That's going to go here. 4x plus 4 is my binomial. That's going to go there. Again, we do number with number, so 2 times 4 is 8. X times x is x squared. Then we do 2 times 4, which once again is 8. And then 1x joins it on the inside. Get my terms down. 8x squared plus 8x. As I check, that's what needs to be in parentheses. The pi that we never used at the front, the pi that we never used over here at the front is just going to stay at the front. So really that's the answer choice that I'm looking for, which matches with answer choice A. Alright, 26. This one's actually going to be pretty big on your test. It says Maria multiplied x minus 2 and 4x minus 1 and got 4x squared minus 9x plus 2. She put the following into her graphing calculator. So into her graphing calculator, she enters both the problem and the answer, or the problem and her answer. So she put in x minus 2 and 4x minus 1. On the bottom, she's going to put 4x squared minus 9x plus 2. Okay, so again, on y1 she put her question, on y2 she puts her answer. Your questions are, how will she know the expressions are equivalent when looking at the calculator, table and graph? So how can she tell that the equations are, and this is the magic word, equivalent. Equivalent means that they're equal in every way, looking at the calculator table and looking at the graph. So if we go second graph. If I go to my table and I look at my table, for y1 and y2, no matter how far we go and no matter where we go, those two values will always be the same. If that's the case, then that means that those two equations are in fact equivalent. So for your table, whenever we were looking for something that's equivalent, on our table, y1 and y2 will always match. No matter where we are in, no matter what x we're looking at, they're always the same. Okay? Now graph. If we go in and we graph both of these equations, even though I typed in two equations, I only see one graph. Now what that means is that we have coinciding graphs. Now if I draw this, sketch this graph out for you guys, what that means is that the first equation that we graphed did this. The second equation that we graphed goes right over it exactly. So really we have one graph on top of the other, which is why we only see one graph on our calculator. So in this, on the graph part, you're going to say we only see one graph. Because, both graphs are on top of each other. Because both graphs are on top of each other and they overlap. All right, 27. 27 says, find the perimeter and area of the triangle shown in terms of x. So we'll go through, again, perimeter and area. Again, with perimeter, we add up our terms together, which means that we need our table. And you start noticing a pattern. When you're adding your terms, it's always with the table. When you're multiplying, it's always with the box. So with a triangle, I'm going to add up all three sides. 2x in the middle is not a side, so I'm going to add all three of those sides. Again, I put them where their terms go, so 4x plus 5. I break it up like this. 3x plus 4. And 7x plus 6. I just add down the row. So 7 plus 3 is 10, plus 4 is 14. 5 plus 4 is 9, 9 plus 6 is 15. So my perimeter is 14x plus 15. For area of a triangle is 1/2 base times height. I always do base times height first, and then whatever answer I get in that box, I just slash it in half. So my base is what my graph is sitting on, which is this. Or sorry, not my graph, my triangle. So that's the base that it's sitting on. This is the height. Sometimes your triangle will be rotated in some way. Wherever the right angle is, that's your base and that's your height. Right, so there, if I drew my little square, that would be my right angle. So that's my base, that's my height. So my base is 7x plus 6, my height is 2x. I multiply base times height, which means that I'm multiplying 2x times 7x plus 6. And I'll show this because of my space. I'll show this with distribution. So if we do 2 times 7, it's going to give me 14. X times x gives me x squared. Then I'm going to do 2 times 6, which is 12. And then x joins it. Alright, so if I distribute, I get 14x squared plus 12x. That's great and all, but I've just done this part here, base times height. Now I have to go through and slash everything in half. Now this part's the easy part. All you do is just ask yourself, okay, what's half of 14? Or what happens whenever I divide 14 by 2? Half of 14 is 7, so I'm going to have 7x squared. Then same thing, I do half of 12, which is 6. So my final answer is 7x squared plus 6x. All right, we'll jump to the last part. On this, I'm only going to work 2. I want you guys to be on 28. I'm only going to work 2. I want you guys to be able to practice on your own checking to make sure that it's equivalent. All right, so 28 says determine if each expression is equivalent to 4x parentheses 4 minus x parentheses 5x minus 1. Right? Yes or no in the each blank. So we're actually going to use our graphing calculator to determine whether it is equivalent. Again, whenever you see a question like this on your test, you're looking for that word there, equivalent. All we're going to do, and I usually check this with my table and not my graph. All we're going to do is type in the original equation. 4x, x minus 4, and then 5x minus 1. I'm going to type in the original equation into y1. Then one by one, I'm going to type these in to y2, and I'm going to just check to see if the table matches. So in y2, I'm going to now type in 4. Let me get to where you can see it. One by one, I'm going to type these in. So in y2, I'm going to type in 4x squared minus 16x. And 5x minus 1. Alright, we type both of those in. I'm going to go to my table, and I'm just going to check to make sure that they match. So as I go down, no matter how far down I go, I see that y1 and y2, those two tables, or those two sides, always match. So that means that it is equivalent. So again, it just says write yes or no whether they're equivalent or not. This one is going to be a yes. Checking the second one. So again, I go back to y equals. Always leave the original, that's fine. We're going to go to y2, we're going to clear that. Again, only check 2 at a time, or 1 at a time. X minus 4 and 20x squared minus 4x. Once again, I can check, and they are in fact equivalent. Right? Everything matches in my y1, y2. So again, this is going to be a yes. I am only going to work 2 because I want you guys to work the other ones on your own just to check, just so you guys get a little bit of practice before the test. All right, and then finally 29. 29 says find the product of each of the following. We have 5x minus 3 times 6x plus 2 times 9x minus 1. And then we also have 2x minus 4 times x squared minus 6x plus 1. All right, so I'll actually work both of these for you guys. These are, I think, a little bit more fun, just because they're a little bit outside the box. No pun intended. So with something like this, we unfortunately can't do, we would need to do like the cube method if we were doing all 3 of these at once. So I'm not going to do that. Instead, I'm going to do just 2 at a time. Once I find these 2, then I can do it with that. So I'm going to do these 2 first. And I'll go ahead and do the box method. Again, I can't multiply 3 sets of parentheses at the same time. So we go in and we distribute. 5 times 6 is 30. X times x is x squared. 6 times negative 3 is negative 18x. 5 times 2 is 10x, and then 2 times negative 3 is negative 6. Again, I'm going to go ahead and do my shortcut, which is that I just say, hey, those two are going to be combined. So my answer here is going to be 30x squared minus 8x minus 6. Alright, so that is my first set. Done. Now I still need to multiply everything by 9x plus 1, or minus 1. So what I'm going to do is I'm going to put parentheses around this, add now the 9x minus 1, and now I'm going to multiply those together. Alright, now this is where it gets a little funky. Now I want to make my box, so now it's not going to be a 2 by 2 box because these I have 2 terms, but on this one I have 3 terms. So I need a 3 by 2 box, which is probably something that you haven't done ever, but it would look something like this. Alright, so we need 6 boxes now. 9x minus 1 is my 2 terms, so I'm going to put that there. 3x squared, or 30x squared is going to go here. Negative 8x is going to go there. And then negative 6 is going to go there. Alright, we take our terms and we multiply them in. Our numbers are going to get kind of big. So we have 30 times 9, which is going to give me 270. Then I have x times x squared. Well, this is already 2 x's coming in. This is 1 x coming in, so really it's 3 x's coming in. Then I'm going to do 9 times negative 8, which is negative 72. X times x is x squared. And then I'm going to do 9 times negative 6. And then 1x came in from the side with the 9. These terms come down. So now I multiply 30x squared times negative 1. 30 times negative 1 is negative 30. X squared comes in. Negative 1 times negative 8 is positive 8. And then 1x comes in. And then negative 6 times negative 1 is positive 6. Okay, from here I don't want to just draw my circles. I'm not going to do it like I did up here. I'm going to actually draw myself a table. Now the only problem is if I do x squared, x in numbers, I have one term that doesn't fit it, which is this, the x cubed. So I actually need to go in and do one more so that I can actually fit all of my terms in there. So I'm going to go ahead and multiply, or just put my terms in. So 270 x cubed goes there. Negative 72 x squared goes there. Negative 54 x goes there. Negative 30x squared goes there. 8x and 6. First term comes down, last term comes down. These are the two that I have to add together. So I'm going to do negative 72 plus negative 30. So I have 270x cubed coming down. Negative 72 plus negative 30 is negative 102. Negative 54 plus 8, negative 46. Whoops, I forgot the x squared for this one. This one comes down with an x, and then 6 comes down. So my final solution here is 270 x cubed minus 102 x squared minus 46x plus 6. Alright, I will leave B for you guys to see if you can work that out on your own. Again, these are a little bit more fun just because instead of your standard 2 by 2, you now have a 3 by 2 because one of those is a trinomial. And of course, don't forget that if you do x squared times x, you get x cubed. Okay. Good luck on your test tomorrow.